Welcome back. In the last video we did some type of prototyping to write a small Android application which can be used to train certain topics. For example, if statements. This bonus video focused on the app development process in Android on a very high level. It can be useful to know these things, but they are not required for this course over here. This course is about Android application hacking, and this is exactly what we are going to do right now. In this video, we simply reverse engineer the application we have written in the last video, and it is therefore not required to watch this bonus video. All that this application is doing is simply just reducing our lives by 1 if we press this button. You will find this APK in the attachment of the section, and you can simply download and get into this video right now. Therefore, let's go! Okay, let's have a look into this code over here, because we want to keep practicing Smiley as often as we can. And we do this together right now. So yeah, we will go through this together and we will learn new instructions and figure out how the if statement works. Therefore, let's go. So let's see what we've got. We've got our virtual method. This means we are having a public method over here, which is labeled getHit. This is our method name. Let's write this down. GetHit. Okay, we can also see this method does not have any parameters. Nice. We can also see the return type is void, so we are not returning anything. That's also nice. All right. There we have our function prototype. Already done, 1 line of Smiley code. Nice. Next we've got locals 2. This means we are having 2 local registers, but we do not know if these are variables or placeholder for certain values. We do the top to bottom approach, therefore we go through this instruction after each other. We do not look this up right now, so we just keep this in mind, okay? We've got 2 local registers, okay. Next we've got I get v0, p0. Okay, we know p0. p0 is a special parameter. This is holding our this object. Okay. Let's see what this instruction does. We have faced this many times right now, but anyway, let's look this up to be 100% sure. It also doesn't take that much time. You will see this. So let me switch. There we go. We have our Dalvik opcodes over here. And yeah, we simply search for this instruction. I get vx, vy, field ID reads an instance field into vx. The instance is referenced by vy. Alrighty. We go back. So we've got an instance field over here, and we can find this instance field after this arrow, which means our instance field is lives. We've got this dot lives. This one over here is just regarding to this object that we know it's from the class player. So this is a player object. Okay, so this is what our p0 is holding. And this value gets now put into v0. And let's write this down. v0 is equals this dot lives. Okay. This, or the p0 register, let's say the p0 register is the only one I like to replace. Otherwise, I like to keep sticking to the original register values. So next we've got const /4 v1 0x1. We are putting this value into v1. And we are only putting 4 bits because of this /4. But this doesn't matter here because the value 1 is 0, 0, 0, 1. Okay, so let's write this down. What this line does is it initializes the register, our second local register, with the value 1. Alrighty, then we've got sub-int to address, and we only got 2 registers. I mean, it's clear what it does, but anyway, let's look it up to be sure where the result is being stored. Is it here or is it here? And do we subtract this from this or vice versa? If we are not 100% sure, simply just look this up. So we are looking for sub-int. This one has now 3 registers, so we have to add this one. Yes. Okay, calculates vx minus vy and puts the result into vx. Okay. So we are calculating this minus this, and the result, let's do this minus this, and the result is being put back again into v0. Okay, so we are having v0, let's switch back, is equals v0 minus v1. which means if we replace now our v0 with the reference over here, so v0 is holding our this.lives, this one. This means our v0 is now equals this.lives minus v1, and v1 is 1. So minus 1. Okay, this is what this line over here do regarding to the setup of the registers before. Okay, next we've got output v0 p0. So we are putting this value over here into our instance back again, our instance field lives. Anyway, let's have a quick look to be 100% sure. I put vx, puts vx into an instance field, the instance is referenced by vy. Okay, we have to take care. I get reads from right to left, and I put this one reads from left to right. Therefore, we are putting this value now in p0. Here we are fetching the value from p0 into v0. So if you're not 100%, okay, you get this point. All right. So let's see. This means we are having p0. And this dot lives is now equals v0. And v0 is this dot lives minus 1. So at this point we are just reducing 1 or subtracting 1 from this dot lives. Okay, let's put an info that we know this is not an instruction, it's just a reminder for us that we are subtracting 1 from this dot lives. Okay. Now, finally, we've got our if statement. Let's have a look. Let's put a dramatic color for this on. So we've got if dash less, maybe less equal, and then this one is 0, maybe. v0, and then we've got this one. This looks strange over here. All right, let's have a look into this. So we look this instruction up first. If dash less equals yes. Okay. Let me scroll down. There we go. Checks vx and jumps if vx is less or equal. We've got 0 squared 2, but having an 0 squared anything is still 0. So I'm not sure why it's pointed out in this strange way over here, but this means if vx is less or equal 0. And afterwards we jump, and we jump to this one over here, the target. Here we can see an example. If less equals 0, v0, okay. And then we jump to this one over here. Jumps to the current position plus this offset. All right. This looks even more strange in my opinion. So let's get back to our code, that we do not get too confused. Okay, the first thing we need to do is you need to read this out loud, and we need to read this in the following way. The first one is if v0. That's the first read. And then the second read is less equals 0, then jump to condition 0. Okay, if you read this out loud in this way, we can write it also down in the exact same way. Let's do this. If v0 is less equals 0, then we jump to condition 0. All right, let's clean this up real quick. Okay, let's find this condition 0 right now. So we've got a colon condition underscore 0. Let's scan. Scan. There we go. Here we have this one over here. Okay, so if this condition is true, we jump from this one to this one over here. We move on at this part in the code. And this is super amazing because this is now our branch. We're having our code, and this code has some branch, true and false. And yeah, by going to the one branch, we are skipping the part of the other code. And this is what we are doing right here. We are skipping this code over here right now. We have to move on in the code. Maybe we will come back to this one. But for now, we are just skipping it, okay? All right, so this is also our true condition. Let's put this true. So if this statement is true, which means this is our true condition. Okay, then we move on over here. Let's see what we're doing afterwards. So we've got our if statement. And now we are putting the value 0 into v0. Okay. So v0 is equals 0. And now we've got an input boolean. This is interesting because our value 0 can have multiple meanings. It can have or can be used as the number 0 or as a boolean statement. A boolean statement or a boolean state is, for example, true or false. These two states. And in this case, we are having a 0, which means a 0 is the state false. So these values can have multiple meanings in this case. Okay, and then we are putting this false back into our this object. And what kind of this object? We will find this after the arrow here. It's the this.state. So we've got an this.state instance field. And we can also see this over here. This.state is from type boolean, which makes sense because we are putting a boolean into this. Okay, this means we've got our this.state is now equals v0, which means our this.state is now equals false because our 0 is a boolean value and it's false. Okay, alrighty. Let's get back to green. What's going on right here? Then we've got this one. Let's mark this real quick. So we got this one. We also got this one. This is just a line number. So yeah, regarding to our Java code. And then we've got this GOTO over here. This looks interesting because this is the second condition. If we have a GOTO starting with those colons over here, in this case, GOTO 0, we can skip this. This is really important because I also struggle a lot at this point. If you later on patch some code and then you came across this instruction, you're thinking about, oh well, now what I have to do? Do I have to jump or can I just leave it? Do I have to delete it? The rule of this is if we've gotten colon and then afterwards in GOTO, we can simply skip this. This will be ignored. So we just go over through this instruction here. Hey, it's me from the future. Within my quality assurance, I stumble across this one over here. And yeah, you know what? We can make this a lot easier. It does of course not only affect GOTOs. So we can keep the following rule in mind. If we are having a colon and afterwards our label, this is a label where someone else in the program is referred to. So we can simply skip this one. But if you're having an instruction and condition, something like this in front of our semicolon, then we have to investigate this because this is a decision which is being made and afterwards we are taking this jump or not. So this instruction cannot be simply skipped. And to summarize this real quick, having a line starting with a colon, this is just the jump reference, we are ignoring this. But having an instruction in front of our colon, then we need to consider this. So we cannot simply skip this. We have to find out what's going on over there and then if we take this jump or not. Alrighty? Perfect. Okay, and afterwards we return from our function. So we also understand this one and this one. Return afterwards. Alright. Okay, this is our if statement true. It looks a little bit messy, but yeah. We introduced some new commands over here or new instructions. We've got our if, which makes a statement and condition. If v0 is less equals 0, that's what the set over here means, the comparison against 0, then we jump to this condition. So this is our true statement. Okay, let's clean this up before it's getting even more messy. Okay, now we have discussed our true statement, but we also have a false case. Therefore, let's have a look how the code looks like regarding to the false, or in this case, the else case. Let's have a look. So we start reading this once again. We say this loud to ourselves. We say, if v0 is less equals 0, then jump to this condition. But now we do not jump to this condition because we are assuming we have a false state. All right, regarding to the false state, we simply move on in the code line. So we are now right here. This means line 22. Yeah, and line 22, this is just our Java reference. So nothing special about this one. Then we've got our output boolean once again. Interesting, let's see. We are putting now v1 into p0. And it's again, p0 is our this. And here we are having the instance field of this, which is state from type boolean. So we can simply write our code here on. So what do we have right here? We've got this dot state is now equals v1. And this is why I like keeping those registers, because we can now look up our code, what was v1 the last time. In this case, we can see this one over here. Afterwards, we subtracted this one, but we didn't reassign this. Therefore, the value is still the same. And here we can see, okay, we didn't use it further. This means our v1 is holding this value over here. And now we are putting a boolean into our this state, which means we are putting the value 1, which means the state true in our this dot state. So this dot state is now equals true based on this one. Okay, so we also got this one over here. All right, now we've gotten GOTO. Let's mark this different. Some purple color. All right. We have now here our jump instruction, because otherwise we would go on in this code over here, and this is this code over here. So the GOTO at the beginning signals afterwards there's a label, and we jump to this label right now. And this is the difference between this GOTO and this GOTO. This one has this GOTO in front and then this colon GOTO underscore 0. So in this case, we are looking for this label over here, and we find this at this line. This means we are jumping from this one over here to this one. Okay, I guess you cannot read this anymore, therefore let's clean this up real quick. So we are jumping from this to this. Way better. This automatically means we are skipping the following part. This, 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 and this. All right, and what is this part? This part is exactly what's in here. And therefore it's good that we've skipped this, otherwise we would interfere with this code over here, okay? So some rules we have to mention. We've gotten if dash less equals 0, then we've gotten condition afterwards, which is a label. If the statement is true, we jump to this label. In this case, it would be here. If the statement is false, we simply move on with our code until we reach this GOTO. It doesn't have to be in GOTO. For example, we could also leave the function right now and there might be no GOTO in there. That's also possible. But if we reach this GOTO, then we have to check the label behind this GOTO. In this case, it's starting with a colon, and then, most of the time, I guess every time, it's having this GOTO underscore 102 and so on. And then we have to look in our code for this GOTO label. And then we jump to this one over here. By doing this, we are skipping some code, which is intended. And then we move on simply right here. So now we've got return void. Let's see. Okay. So afterwards, we are returning out of this function. And this is what the code looks like. And this is super interesting, isn't it? Because if you take a close look onto this, maybe you figure out something. I will give you some moments and I will come back afterwards. Let's have a look into this code and see if there's something strange going on. A few moments later, let's create some space first. So let's get rid of this one. All right. And now, can you still remember how the Java code did look like? Yes, interesting, isn't this? Our Java code was looking like this. So we've got our if, then we've got this dot lives is greater than 0. I'm pretty sure this was what our Java code looks like. So did we make a mistake over here? Did we do something wrong? Absolutely not. We did interpret this code absolutely correctly. We go through this line by line, and this one is the correct code extracted from the smiley part. So now's the question, do we get the same result? It would be ridiculous if not, right? Let's have a look. So in our case, in our Java code, we have this dot lives greater 0, then move on. Otherwise, we lose the game. Let's see. Now we've got if v0 is less equals 0. Okay, this means we are not having any lives left, right? Because this is what we get if we are having 0 or less than 0 lives. Then we have the statement over here. Interestingly, that's correct. We are putting our this.state into a false mode. This was exactly the part we got in our Java code in the else case. And here we've got, okay, this means we are having more than 0 lives. This part over here. And here we can see, yes, we can move on with the game because we have our this state equals true. Okay, so now is the question, why is the compiler doing this? Well, this might be regarding to compiler optimization. For the computer, it might be faster to calculate if we've got less or equals 0 lives than calculating if we've got more than 0 lives. And this is why the compiler has chosen to build this code in this instruction over here, in this way. And in my opinion, this is really amazing. Why? Because we are even more or even closer to the original part than the Java code. Because here we can see what's going to be executed. We are not checking if the value is greater than 0. No, we are checking if the value is less than 0. And then we go into this instruction over here. Otherwise, we move on this part here. And in my opinion, I find this super amazing because we are more exact than the Java code. Ridiculous if we check out the Smiley code over here. Okay, so you see I'm super hyped up about this. And the first time I was really confused because I thought, okay, there must be a mistake over here. Then I checked the code and I realized, wait, what? This is exactly the same code, but a little bit different. Just in a different order, but still correct result. And yeah, this was absolutely mind-blowing for me. Okay, beside all my hype right now, let's get back to the if statements. What have we learned? Therefore, let's clean this up real quick. So, okay, if we get to an if statement, we have several points to consider. First of all, we have to check what's the statement. We read it in the following way. If v0 less than equals 0, go to this condition. This is our true statement. Then we ignore the rest of this and we jump to this condition or this label over here. This one. Therefore, this code will be ignored for now. We simply move on, and if we encounter in GOTO starting with a colon over here, we simply ignore this because this is not regarding to our instruction. Okay, then we have to do this once again regarding to the false statement. And within the false statement, we ignore this target over here and we simply move on with our code until we get to a GOTO and this label afterwards. Then we jump to this label and we move on this part right here. This means we are ignoring all the rest. All right. I know, if I look at this picture over here, it might be a little bit confusing, but don't worry. We go through this several times. We will also take a look into some slides and we will keep practicing a lot because this time we are only comparing against a 0 value. There's also an additional if case if we've got two register values. Something like if v0 is greater than v1, for example. Then we get an additional register over here, but we will learn this later on. For now, we just focus on the comparison against 0, and then we simply introduce a new register into this, and the rest keeps the same. Okay, that's all for this video right now. In the next one, we do the same approach, but on our slides, which looks a little bit more clean. And we will go through this further and further. If you've got some questions, feel free to write me, of course, but maybe they might be also clarified in the next videos, because we will keep practicing this over and over again. If statements are super important, and therefore let's move on in the next video.